Okay, so let's take a look at what universal gravitation is. It is something, it's not exactly gravity, because gravity is specific for a certain planet or a certain object. This one calculates things, the force between two objects based on the mass. So if you look at the formula, it's based on the masses of the two objects and r, which is the distance between them. G is the same everywhere in the universe. It does not matter what planet you're on. Large G is always this number right here. I will give you this number. Don't try to memorize it. I will give it to you. The little g, remember little g, that is the gravity of whatever planet. So for example, the gravity of Earth, if you remember, is 9.81 meters per second squared, because it's an acceleration. But here we're going to use large g. Okay, R, I want you to remember that R and D are pretty much the same thing. I know that's radius and that's distance, but for this formula, I've seen it written both ways. I've seen it written with an R and I've seen it written with a D. So what does that mean? Either R or D, whatever is in the formula, is the distance between the center of one object and the center of the other. For example, here I've got two things that are touching. Here they're not touching, so the distance is going to be much more. Here it gives you the radius, and since they're touching, the distance is going to be the sum of both of those. Okay, remember that mass is in kilograms. Remember that distance is in meters. Okay, let's take a look at an example. So here, let's take these two. I've got two different objects. They're 1,000 kilograms each. So we're going to calculate the force. So I'm going to use this formula up here. So force equals G. So I'm going to write G down, which is this right here. Newton meter squared over kilograms squared. That are the units. Okay, then I'm going to multiply by the two masses. So I'm going to multiply 1,000 times 1,000. I'm going to divide it by, if you'll notice, r squared. So r squared is the distance between the center of the two, and if I add these together, it's going to give me 0.6 meters squared. So I'm going to take this number times 1,000 times 1,000, and then I need to square this. Okay, so actually, let's do that. Okay, so if you'll see the calculator, we're going to square this number. So I'm going to type in 0.6 times 0.6, and that's going to give me the square. Okay, so 0.36, and that's going to be meters squared. So now I'm going to take this number. If you remember our scientific notation, remember that you have to not put in the times 10. So this times 10, do not put it in. So I'm going to show you how to type it in. So this is what you're going to have to do on tests and quizzes. 6.67. Do not put times, do not put 10. Look for the EXP button right here. And then I'm going to put in negative 11. Do not put this. This is subtract. This is your negative. So I need negative 11. Negative 11. This is what it should look like. 6.67. You got a little negative 11 at the top. So that is your exponent. On paper, we write times 10 to the negative 11. Here, we don't put times 10. Okay, I'm going to take now and I'm going to multiply it by 1,000. Okay, I'm going to multiply it by another 1,000 because that's the mass of the other one. At this point, since I'm going to change from multiplying to dividing, I like to hit the equal key. That gives me an answer. Now I can divide it by not 0.6. I need to do it by the square, this number here. So I'm going to divide by 0.36. That is my answer. And as you can see, this is in scientific notation. So I have 1.85. I can drop the rest of it. Then I have times 10 to the negative 4. So if you remember your scientific notation, -4, I would take, and that decimal, I'm going to move it 4 places to get a smaller number. 1, 2, 3, 4. Okay, now fill in with zeros. So notice I have 3 zeros and then 185, which is exactly what I have here. If you write it like this or write it like this, both answers are correct. Okay, so suppose that 1,000 kilograms, let's suppose that it was a small car. So if I have 2 cars that are touching each other, what is the gravitational force? It's this many newtons. A newton is approximately how much energy it takes to lift an apple 1 meter up above a table. So it's pretty small. And then we'd have this much, so the gravitational force between those two, there is a force. It is just, it's very, very tiny. So gravitational force is not very strong, but I still want you to understand how to calculate it. Okay, let's do a little reviewing on scientific notation. It's a way of representing numbers to simplify the way that they are written. Okay, the normal number would be this. This is your normal number. This is scientific notation. Okay, I went over this in a prior video, so if you're not understanding this, go back and watch my video. So, for example, if it was a large number, I'll have a positive sign. So, my exponent is positive. Why? Because I had a large number. I had 3,455. So I'm going to move the decimal. If you do not see a decimal, it's at the end of the number. So you're going to move it over until you have a number and then your decimal. Then you tell how many places you moved it. So you moved it 3 places. Okay, here you're going to have a negative sign because it's a very small number. I still want to move the decimal until I get it right behind the first number. So in this case, I'm going to go 1, 2, 3, 4, 5. So I'm going to have exponent 5. Since it was a small number, I'm going to have a negative exponent. Okay, so just remember to use this on the calculator. Do not type in times 10. Okay, so let's type these in. I want you to understand how to get these in the calculator. Okay, so first of all, I'm going to type in 4.6. Do not put times 10. I'm going to look for the EXP button. Then I'm going to put negative, not the minus, but negative 4. Now I'm going to hit the multiply. Now I'm at the multiply, and then I'm going to put this number in. 5.93. I'm going to put exponent, and I'm not going to hit the negative. I just want 5. And that is my answer. Okay, now this is my answer, and I'm going to round it. You can keep the 5. I tend to not want to write too many numbers. 3 or 4 is good. So I'm going to round this to 2, 7, and then that 2 is going to be rounded up by the 7. That 7, if it's 0.5 and up, it will round it up. If this were 0.4 or lower, then I would just leave it 272. All right, let's try this one more. Okay, so I'm going to type in 7.2. I'm going to hit exponent. I'm going to hit negative 2. I'm going to divide by 1.33. I'm going to hit exponent 2. And there is my answer. Okay, you can see I have a whole lot of numbers. I do not want to write all of those. I'm going to write 3 or 4. So I'm going to put 5.41, and I could put a 4 if I wanted to, and that would be fine. Just don't put too many. Okay, and then right here it says a negative 0.4, and so I'm going to put times 10 to the negative 4. Because on paper you have to write the times 10, but you don't put it in the calculator. Okay, so hopefully that gave you a refresher on how to type in numbers in scientific notation. So let's actually do a calculation like I expect you to do on the next quiz. Okay, so calculate the gravitational force. So over here I have force equal, I don't know, I'll put a question mark. Okay, mass of Jupiter is this. Okay, so I have mass 1. This is my number. This is way too big, way too many zeros to put in the calculator. So let's use this. So I put in mass 1, and I want to write that number right here. It's Moon Europa. Okay, so this is mass 2. Let me put that up here. Mass 2 is this number here, and I'm going to write it over here because you have to do this by my 4-step method. So all of the data goes here. Okay, they're separated by a distance, and so this right here is my distance. Now, distance, I can use D or I can use R. Okay, here they're using R, so we'll use R. So I'm going to take this distance, write it here, and then I'm going to go ahead and square it. It's much easier if you go ahead and square it here than try to do it over this way. Okay, so if I take this number, 6.7, and then I'm going to put in my calculator, I'm going to put 6.7 exponent 8. And then I'm going to type in again times 6.7 exponent 8. And that gives me that. I can also use my square button. So let's try that. 6.7 exponent 8. And I'm going to hit the x squared. Okay, so now that we've squared it, now they're rounding it to 2 places. That's fine. If you want to type in 4.489 like we got, times 10 to the 17, that's fine. For these calculations, I will take either one of these. If you round it a little too much, I will not count off. Okay, so here is my formula, and it tells me what to do. So I write G, there's G. I'm going to multiply that by mass 1. I've got mass 1 here. I need to multiply that by mass 2. Here's mass 2. And then I'm dividing by this, which I have already squared. Okay? So I'm going to take this answer right here and put it there. Okay, now let's type it in the calculator. Okay, so I will put in 6.67 exponent negative 11 times this number, 1.9 exponent 27 times 4.8 exponent 22. Those are my 2 masses, and I want to hit equal. May or may not matter, it depends on the calculator you're using. I like to hit equal because I'm changing from multiplication to division. And I want to make sure the calculator understands what I want it to do. Okay, I'm going to hit divide by, and then I'm going to put 4 point, I'm going to use my whole number. Okay, and I'm going to hit exponent 17 equal. Okay, I'm going to take this number, and I only want to use 3 or 4 numbers. So 1.35 or 1.355, and don't forget the exponent, which is 10 to the 22. My units for these are you're only going to calculate the force, and so that will be newtons, because newtons is the unit of force. Okay, let's take this number too, or the second problem. Okay, so calculate the force. Okay, so F equals, I don't know, and I've got it right here. 2 objects, mass of this, kilograms. So this is mass 1, and this is mass 2. Separated by a distance of 1 meter. So that was my distance, and I can use R also. Okay, so I've got this number here. Remember, that's always given to you. Mass 1, I didn't put the number in. Let's put it in. So 70 kilograms. Mass 2, let's put that in. 2,000 kilograms. Okay, the distance is 1. If I take 1 times 1, that's just going to give me 1, but it's meters squared. Okay, this is how I want you to write it out. Put G first, so 6.67 times 10 to the negative 11. Then I want you to write out the units. I will count off if you do not put these. Okay, I'm going to multiply by my first, so that's times 70 kilograms. I'm just going to continue here, times 2,000 kilograms, and I'm going to put this all over 1.0 meters squared. Okay, so let's try putting this in the calculator. Okay, so I'm going to type in 6.67, and I want you to do this also. Okay, I'm not going to put times, I got to put exponent, negative 11. We'll jump over here, times 70 times 2,000. I'm going to hit equal. I'm going to divide by 1. Even though I divide by 1, I already know that it's going to give me the same answer. Okay, so let's write this over here, 9.338 times 10 to the negative 6. And this is going to be newtons.